Assalamualaikum. Today I, Afi and Zed will be talking about space weather. (9.1) Definition of space weather. Space weather refers to the environmental conditions in space primarily influenced by the sun. It includes phenomena such as solar flares, solar winds, and geomagnetic storms. Space weather affects Earth's magnetosphere, ionosphere, and thermosphere.
Next, the structure of the Sun. The deepest part of the Sun is called the core, the center of the Sun, where temperature reaches about 15 million degrees Celsius. This is where nuclear fusion occurs, converting hydrogen into helium and releasing vast amount of energy. The second layer, called the radiative zone, just outside the core. Energy travels outward via radiation. In this zone, energy moves very slowly because the plasma is so dense that photons, which is light particles, get scattered in many directions.
Structure of the Sun Part 2. Next is the photosphere, the visible surface of the Sun that we can observe from Earth. It's where sunlight is emitted. The temperature here is about 5,500 degrees Celsius. Next is the convective zone. In this outer layer, energy is transferred by convection. Hot plasma rises to the surface, cools, and then sinks back down, creating convection currents. This process helps transport energy from the interior to the outer layers.
Structure of the Sun Part 3. Chromosphere, a thin layer above the photosphere. Seen during solar eclipse as a reddish glow, it's hotter than the photosphere, with temperature ranging from 4,000 degrees Celsius to 25,000 degrees Celsius. The last one is corona, the outermost part of the Sun's atmosphere, which extends millions of kilometers into space. The corona is very hot, with temperature reaching up to few million degrees, and it's visible during total solar eclipse as a white halo around the Sun.
Next is the phenomenon that occurs on the Sun. First is granules. Granules are small, grainy patterns on the surface of the Sun caused by convection. Each granule is a cell of hot plasma rising from the Sun's interior, cooling as it reaches the surface and then sinking back down. Next is the sunspots. Sunspot is a darker, cooler region on the Sun's surface formed by magnetic activity that inhibits convection. Sunspots typically appear in pairs and are cooler than the surrounding areas, making them look darker. Lastly is solar cycle. Solar cycle, an approximately 11-year cycle of the Sun's magnetic activity, characterized by the increase and decrease in sunspots and solar phenomena like solar flares and coronal mass ejections. At its peak, which is the solar maximum, many sunspots are visible. During its low solar minimum, there are few.
The second phenomenon is the prominence, a stunning display of solar prominence erupting from the surface of the Sun. The image shows vibrant, glowing plasma arcs extending into space, with bright fiery orange, red, and yellow hues, contrasted by the deep blackness of the space. The Sun's surface is textured with visible granules and intense, swirling motion. The prominence arcs gracefully curve and twist, with fine details capturing the dynamic energy of the event.
Next is the solar flares. Solar flares, a dramatic image of solar flares erupting from the Sun's surface. Intense bursts of bright light, fiery orange and red plasma shoot out from the Sun with chaotic radiant energy. The flares twist and spiral, creating brilliant explosions against the dark backdrop of the space. The Sun's surface appears turbulent, with swirling storms of plasma and glowing regions where the flares originate. Next is the coronal mass ejection, an awe-inspiring image of a coronal mass ejection erupting from the Sun. Massive arcs of plasma and magnetic energy shoot out into space in a brilliant explosion. The glowing plasma is a mix of bright orange, reds, and yellows, swirling as it expands upwards, with the Sun's surface appearing turbulent and active. The scale of The scale of the coronal mass ejection is immense, dwarfing the Sun as it reaches into the dark vacuum of space, creating a powerful visual of solar energy and magnetism in motion.
The last phenomenon is the most amazing phenomenon. That is solar wind. Solar wind is a stream of charged particle, which is mainly electrons and protons emitted from the outer layer of the Sun, called the corona. This plasma flows outward into space at high speeds and spread throughout the solar system. The solar wind interact with planetary magnetic fields at an atmosphere, causing phenomena like aurora on Earth. It also affects space weather, influencing satellite operation, GPS system and communication networks.
Next is the Earth's magnetosphere. Earth's magnetosphere is like an invisible shield around the planet. It protects us from dangerous particles coming from the Sun, called solar wind. This shield keeps our atmosphere safe and prevents harmful radiation from reaching us. The side facing the Sun is squished, and the opposite side stretches out into a long tail. It's essential for protecting life on Earth from space dangers.
So now we're talking about the formation and the importance of Earth magnetosphere. What is formation of Earth magnetosphere? Magnetosphere is formed by the interaction between the magnetic field brought by the solar wind and Earth magnetic field. As the number and energy of particles brought by the solar wind change, the shape of the magnetosphere also changes. So, what is the importance? The importance of magnetosphere is to protect Earth from adverse effects caused by dangerous particles from the Sun or other bodies in the universe.
That's all from us. Thank you.